Every year, the world runs more and more on batteries. Electric vehicles passed 10% of global vehicle sales in 2022, and they're on track to reach 30% by the end of this decade. Policies around the world are only going to accelerate this growth. Recent climate legislation in the US is pumping billions into battery manufacturing and incentives for EV purchases. The European Union, or the EU, and several states in the US passed bans on gas-powered vehicles starting in 2035. The transition will require lots of batteries, as well as better and cheaper ones. An international team of researchers led by Dr. Shenlong Zhao from the University of Sydney has developed a new battery that has the potential to significantly reduce the cost of transitioning to a decarbonized economy. What type of battery is being referred to? How does it play an inevitable role in this industry's transformation? Welcome to the latest episode of Tesla Car World, where we will explore the most recent updates. Thank you for joining us today, and if you haven't already, please subscribe to our channel and enable notifications to stay up to date with our future video releases. Without further ado, let's delve into today's topic. Advanced battery technology involves the use of sophisticated technologies and materials in the design and production of batteries to enhance their performance, efficiency, and durability. Today, we want to give you a full view of a battery called sodium-sulfur batteries, also known as NAS batteries, which are a type of energy storage system that uses a molten mixture of sodium, with sulfur being the electrolyte, and sulfur as the electrolyte. What is the new battery's storage capacity? The battery has 4 times the energy capacity of lithium-ion batteries and is much cheaper to produce. The team used sodium-sulfur, a type of molten salt that can be extracted from seawater, to create the battery, making it a more cost-effective alternative to lithium-ion batteries. Although sodium-sulfur, or NAS batteries, have existed for more than half a century, they have been an inferior alternative, and their widespread use has been limited by low energy capacity and short life cycles. Using a simple pyrolysis process and carbon-based electrodes to improve the reactivity of sulfur and the reversibility of reactions between sulfur and sodium, the researchers' battery has shaken off its formerly sluggish reputation, exhibiting super high capacity and ultra-long life at room temperature. The researchers say that the NAS battery is also a more energy-dense and less toxic alternative to lithium-ion batteries, which, while used extensively in electronic devices and for energy storage, are expensive to manufacture and recycle. Dr. Zhao's NAS battery has been specifically designed to provide a high-performing solution for large renewable energy storage systems, such as electrical grids, while significantly reducing operational costs. According to the Clean Energy Council in 2021, 32.5% of Australia's electricity came from clean energy sources, and the industry is accelerating. Household energy storage is also growing. According to a recent report, a record 33,000 batteries were installed in 2021. But what advantages does it pose in terms of price? Our sodium battery has the potential to dramatically reduce costs while providing 4 times as much storage capacity. This is a significant breakthrough for renewable energy development, which, although it reduces costs in the long term, has had several financial barriers to entry, said lead researcher Dr. Zhao. When the sun isn't shining and the breeze isn't blowing, we need high-quality storage solutions that don't cost the earth and are easily accessible on a local or regional level. We hope that by providing a technology that reduces costs, we can sooner reach a clean energy horizon. It probably goes without saying, but the faster we can decarbonize, the better chances we have of capping global warming. Storage solutions that are manufactured using plentiful resources like sodium, which can be processed from seawater, also have the potential to guarantee greater energy security more broadly and allow more countries to join the shift towards decarbonation. So what other characteristics does sodium-sulfur batteries have that make it one of the best battery technologies of the future? The NAS battery is used in a variety of applications, such as peak shaving, load leveling, and emissions reductions. They may be utilized in power supplies and as a central feature of a smart grid, or to provide power for ancillary services, grid frequency controls, and reactive power compensation. Being able to provide power for 6 hours or more, a single NAS battery system can be used for long energy shifting. grid frequency control, and emergency power supply. Next is the advantage of its compactness. The 200 kilowatt/1200 kilowatt hour battery is compact and easy to store, available in a 20-foot ISO shipping container. Thanks to fully containerized battery units, clients can save money on transportation and construction. The NAS battery has less capacity deterioration and no need for battery replacement until the end of its life, which is about 15 years or around 4,500 cycles. The batteries work in many environments with ambient temperatures between -20 to around 45 degrees Celsius. Because sodium and sulfur are abundant throughout nature, raw material depletion is not a concern. Clients who are concerned about the impact on the environment can rest easy knowing these raw materials will always be in abundance. Finally, easy operation and maintenance. With no self-discharge and no uniform charge required, preventative maintenance is minimal because consumable parts only need to be replaced periodically. It's also possible to schedule maintenance, which will avoid interruption at peak operation. For the most intuitive look, we also want to show the unoptimized characteristics of sodium-sulfur batteries. The battery type's main disadvantage is that it requires a heat source for operational conditions. This makes the battery more or less immobile and impractical for residential use, especially when compared to the lithium-ion rechargeable batteries currently employed on most mobile computing devices. Most unfortunate of all is that it drains part of the battery's efficiency since the heat source needed for continuing operation is maintained using part of the battery's own stored energy. So when will it be used in the EV industry? The Ford sodium-sulfur battery is being evaluated for applications in EVs. The required power and energy ratings of a battery to achieve acceptable performance and driving range for a specific commuter-type vehicle are being calculated and discussed. We'd love to hear your thoughts on sodium-sulfur batteries. How do you see them performing in comparison to lithium batteries, and which one do you believe will prevail as the battery of the future? Please share your thoughts with us in the comments down below. Elon Musk, the visionary CEO of Tesla, recently made an exciting announcement that is set to transform the future of electric vehicles. Musk revealed a special, new battery technology that boasts never-before-seen features, including a 20% increase in energy density and a 50% reduction in production costs. This breakthrough technology is a significant milestone in the development of electric vehicles as it addresses some of the most critical challenges faced by the industry, such as range anxiety and affordability. With this new battery, electric vehicles will be able to travel longer distances on a single charge and become more affordable, making them accessible to a broader range of consumers. The implications of this technology are far-reaching, and it has the potential to accelerate the transition to a sustainable energy future. So, what is this battery made out of, and will it deliver on the promises that Musk has made for the future of EVs? Lithium polymer battery, often referred to as LiPo, is a rechargeable battery technology that has gained immense popularity in recent years due to its superior performance and versatility. It uses a polymer electrolyte, which is a solid-state material, as opposed to the traditional liquid electrolyte used in other battery types. So what exactly is lithium polymer? A lithium polymer battery is a type of rechargeable battery that uses a polymer electrolyte instead of a liquid electrolyte. It is a type of lithium-ion battery which is commonly used in portable electronic devices such as smartphones, tablets, and laptops. LiPo batteries are known for their high energy density, low self-discharge rate, and relatively long cycle life. They're also known for their ability to be manufactured in a variety of shapes and sizes, which makes them ideal for use in small and lightweight devices. However, LiPo batteries can be more sensitive to overcharging, over-discharging, and physical damage compared to other types of batteries, so proper handling and charging procedures are important to ensure their safety and longevity. So how much does this kind of battery cost? The price of a lithium polymer battery can vary widely depending on factors such as its capacity, voltage, and size. Additionally, prices can vary depending on the manufacturer, seller, and market conditions. As of our source cutoff in September of 2021, the price of a typical LiPo battery for a consumer electronic device ranged from $5 to $50 US. The price of LiPo batteries used in electric vehicles is generally much higher than those used in consumer electronics due to the larger size and higher capacity required for EVs. The price of a lithium polymer battery pack for an EV was estimated to be around $100 to $200 per kilowatt hour of storage capacity. This means that a typical EV battery pack with a capacity of 50 to 100 kilowatt hours could cost anywhere from $5,000 to $20,000 US. However, prices can vary widely depending on the specific battery technology, manufacturing process, and supply chain factors. However, it's worth noting that the prices of both types of battery have been steadily declining in recent years due to the advancements in manufacturing processes and increased competition in the market. As a result, the price difference between lithium polymer and lithium-ion batteries has become less pronounced. Ultimately, the choice between these two battery types will depend on the specific requirements of the device and the user's budget. Let's compare some advantages and disadvantages of LiPo and lithium-ion batteries. The qualities of LiPo batteries are suited to thin smartphones, tablets, and wearables. While LiPo made a splash in radio-controlled hobbies and still remains an option, lithium-ion is making a return due to its better discharge abilities. While pouch-type standard lithium-ion batteries exist, they still require external casing to prevent expansion that would otherwise become a performance and safety issue. Current LiPo batteries are actually more of a half step away from lithium-ion batteries, as they don't use a true lithium polymer solid, as the original Bell Laboratory designs of the 1970s had, because these solid polymers don't perform well at room temperature. Both battery types use the same materials for cathodes and anodes. The real internal difference between the two is that the insulator between the electrodes is made of a microporous polymer in LiPo rather than the traditional porous film separator used for lithium-ion. The choice between lithium-ion and LiPo depends on the application it's being chosen for. Today, LiPo's batteries have a shorter shelf life but a longer self-discharge time. Longer self-discharge makes them better for devices that might sit unused a few days here and there. LiPo also has a leg up in fitting tiny and slim form factors. On the other hand, LiPo has worse low-temperature discharge than traditional lithium-ion, and discharging LiPo batteries to ultra-low voltages can be dangerous. Deep, fast charges may cause expansion, combustion, or even explosion. Lithium-ion cells have better performance for very high drain uses. Both LiPo and lithium-ion batteries require special smart chargers and often require circuit protection for the safest use. So, what will the future of lithium polymer batteries look like? The future of EVs is bright, and lithium polymer batteries are set to play a significant role in the industry's growth. One of the most exciting developments in the LiPo battery industry is the announcement that Tesla's CEO Elon Musk plans to use this technology for the company's electric car batteries. Musk has announced that the new LiPo battery technology will be available in Tesla cars as early as 2024, offering an estimated 50% reduction in production costs compared to the current lithium-ion batteries. This reduction in cost is expected to make electric vehicles more accessible and affordable to the general public. Compared to traditional lithium-ion batteries, LiPo batteries have a higher energy density, meaning they can store more energy per unit weight. This increased energy density translates to a longer driving range for electric cars, making them more practical for daily use. LiPo batteries are also known for their longer lifespan and reduced self-discharge rate, resulting in lower maintenance costs and a better overall ownership experience. Furthermore, LiPo batteries have greater flexibility in terms of shape and size, enabling them to be integrated more efficiently into the design of electric cars. This flexibility opens up new possibilities for car manufacturers to create more aerodynamic and space-efficient vehicle designs, improving their performance and overall efficiency. In addition to Tesla, other car manufacturers are also investing in LiPo battery technology, with some already incorporating them into their electric vehicles. As this technology becomes more widespread, we can expect to see a significant increase in the production of electric cars, resulting in a more sustainable future for the transportation industry. In conclusion, the future of electric cars looks promising with the introduction of LiPo batteries. With their higher energy density, reduced production costs, and improved performance, LiPo batteries are set to revolutionize the electric vehicle industry, making electric cars more practical, accessible, and affordable for the masses. As the technology continues to evolve, we can expect to see more car manufacturers embrace LiPo batteries, driving the transition to a more sustainable transportation future. What are your thoughts on this new battery? Will it be able to replace lithium-ion in the future? Let us know your thoughts in the comments down below. Tesla has announced a massive investment in its battery factory located in Giga, Nevada. This investment is a clear indication of the company's commitment to revolutionizing the global automotive industry through the widespread adoption of sustainable energy solutions. Tesla's battery technology has already demonstrated significant potential in terms of improving the performance and efficiency of its electric vehicles, and this investment in Giga Nevada will only accelerate this trend. The factory's expansion will create more job opportunities and bolster the local economy. With a promising future ahead, Tesla is poised to lead the charge in the development of renewable energy solutions and the reduction of carbon emissions. Which begs the question, how are Elon Musk's battery factory investment projects, and how will Tesla develop in the near future? All that and more in today's episode of Tesla Car World. Tesla has officially announced its expected new battery and semi-factories in northern Nevada, along with $3.6 billion in investment to make them happen. But are these actually new factories, or simply the completion of Gigafactory Nevada to its originally planned size? We reported on the Nevada governor hinting at plans for Tesla's new factory, which were expected to be officially unveiled. Tesla has now put up a blog post describing its progress with its previous investments in Nevada and the plans for this new investment. So how's this investment project going? Tesla says that it has already spent $6.2 billion in Nevada and hired 11,000 employees while creating 17,000 local construction jobs building out its Gigafactory there, and that the company has produced 7.3 billion battery cells, or around 37 gigawatt hours or more annually, 1.5 million battery packs, 3.6 million drive units, and 1 million energy modules for a 14 gigawatt hour plus total. These numbers are higher than Tesla's original 2014 plan, which was to spend $3.5 billion on a factory to produce 35 gigawatt hours of batteries annually, which would then hire 6,500 employees. Since then, the EV market has expanded rapidly, which means 35 gigawatt hours is still not enough to fulfill global demand for Tesla's EVs. Tesla said, "We will be investing over $3.6 billion more to continue growing Gigafactory Nevada, adding 3,000 new team members and 2 new factories, a 100 gigawatt hour 4680 cell factory with capacity to produce enough batteries for 2 million light-duty vehicles annually, as well as our first high-volume semi-factory." Tesla's announcement is unclear about whether these factories will still be on the same property as its current Gigafactory, which is still about 60% complete when comparing renders to the current status of the building. Judging by the new render, these new factories may be in the same building, compared to the existing building which has an L shape, and the original and new renders of the building. Filling out the L shape would complete the building to look more like the renders. The announcement mentions that some of the $3.6 billion will be spent to continue growing the Gigafactory, but also build 2 new factories. Previously, we reported that Tesla was building a production line for the Tesla Semi in a new building near Gigafactory Nevada, so we're not sure if it's changing plans and will bring all this production under the same roof or continue expanding that new building nearby. The new render shows assembled Tesla Semis coming off the line on the left side of the building, which could suggest that their assembly will be done under the same roof, or maybe it's just a render. This announcement comes the day before Tesla's earnings report, which is certainly interesting timing. Tesla set a record for deliveries with 405,000 vehicles delivered in the fourth quarter and 1.3 million in all of 2022, though the fourth quarter number came in short of their expectations. Near the end of the quarter, Tesla started offering discounts and has recently drastically cut prices, signaling that it needed to stoke demand a little after more than a year of significant price increases while EV demand skyrocketed. But that's just the $3.6 billion Tesla project in Nevada. According to the latest information we received, South Carolina has also become the next hotspot for batteries with an investment of $1.6 billion. A series of massive investments from Albemarle and Cerba Solutions is set to make South Carolina a hotbed for lithium battery production. The first and significant larger investment comes from Albemarle, the world's largest lithium extraction and refining company, which has announced today that it will be investing $1.3 billion into a new lithium refining facility in the state. Construction of the facility will begin sometime in 2024, and once opened, the facility will be able to refine 50,000 tons of lithium annually. Albemarle plans to supply the facility with lithium from recycled batteries and hard rock lithium mined in its home state of North Carolina. Albemarle's massive South Carolina push comes amid a squeeze on lithium generally, with many corporations looking to enter the extraction and refining business in the coming years, including one prominent Albemarle customer, Tesla. Speaking of, Tesla is also well on its way toward establishing a lithium refining facility and has reportedly even gone as far as considering purchasing a Brazilian lithium mining company. The second significant investment announced today is from Cerba Solutions, a North American battery recycler hoping to establish another recycling plant in South Carolina. Investing a total of $300 million, Cerba's newest facility will focus on extracting and recycling lithium, cobalt, and nickel, all of which are materials that have received significant criticism for their dubious methods of extraction. The new recycling facility, set to begin construction in the second half of 2024, is the second Cerba has announced recently. The first, which has received $75 million in government backing, is being placed in northern Ohio. These new facilities are just two of many being established in what is being called America's Battery Belt. This area, stretching from South Carolina and Georgia in the south all the way to Wisconsin and New York in the north, is being filled with numerous facilities from other battery industry leaders, including a strong contingent of South Korean companies that include LG, SK On, and others, as well as newer startups like Li-Cycle in upstate New York. Tesla did not say when it intends to break ground on the new factories, nor when it expects to start production on cells and semis. It's likely that the cells produced there will go directly into the semis, since Musk had previously said supply chain challenges and limited availability of battery cells contributed to the multiple production delays of the truck. Musk had originally introduced an electric Class 8 truck prototype back in 2017 and planned to start production in December of 2019, but Tesla only managed to start producing semis in October of 2022, 3 years later. How do you feel about Tesla's new battery factory expansion projects? What breakthroughs will it bring in the coming years? Let me know your thoughts in the comments down below.
You know, I think one of the things that troubles me most is that we don't yet have a truly affordable car, and that is something that we will make in the future. But in order to do that, we've got to get the cost of batteries down. We've got to make, and we've got to be better at manufacturing, and we need to do something about this curve. The curve of the cost per kilowatt hour of batteries is not improving fast enough.
Elon Musk has said that batteries are key to scaling electric vehicle production and moving towards sustainable transportation. New battery cells other than the 4680 will appear and break into Tesla's Model Y, making it superior to the competition. So what amazing advantages are in store for the world of EVs?
特斯拉不管怎么说，它是一个很成功的一个企业。比亚迪是非常对，比亚迪很尊重特斯拉，我们也很佩服特斯拉。我们现在跟伊隆马斯克也是好朋友。是吗？因为我们也给他马上也给他供电池，对，我们也给他，大家也是一个朋友关系。首先他起点比较高嘛，他采取的高举高打，他在美国在这种资本市场融资也很。
As rumors from a year ago anticipated, a prior supply contract had already been signed between Tesla and BYD, or Build Your Dream, On October 21st of last year, a source close to BYD told a local Chinese media outlet that the manufacturer had received an order from Tesla for 10 gigawatt-hours of LFP batteries. In early June, BYD Executive Vice President Lian Yubo announced in an interview that BYD would soon supply batteries to Tesla. On the afternoon of August 10th, a number of people familiar with the matter revealed that the Blade battery supplied by BYD has been delivered to Tesla's Gigafactory in Berlin, Germany, which is also Tesla's first superfactory to use BYD batteries. Tesla vehicles can roll off the assembly line in as little as 1 month, that is, from the end of August to the beginning of September. This is a surprising turn of events if it turns out to be true, but neither Tesla nor BYD are confirming it right now, though BYD has previously confirmed plans to supply Tesla with battery cells. Tesla's CEO Elon Musk has said that ramping up battery production is crucial if electric vehicle adoption rates continue to rise. They plan to purchase every available battery cell available. Chinese sources said that Tesla had some of the most stringent requirements on the thickness and precision of the batteries they were getting. BYD really had to work hard and improve its processes with the next generation Blade battery to meet the Tesla standard. Then, some information revealed that the second factory using this battery line is Giga Texas. Tesla's Model Y along with the Semi are expected to be built by the new BYD Blade battery in early 2023 to hit its target of 3 million vehicles per plant. Promising this battery innovation will bring a lot of positive reception from Tesla fans. So, is the BYD Blade battery better than the 4680 cell? Documents refer to the new Model Y variant as the Type 005, and internally as the Y7CR variant. The BYD battery capacity is rated at 55 kilowatt-hours, providing a range of 273 miles. The BYD Blade battery single-cell design is compact, measuring 37.7 inches long, 3.5 inches wide, and half an inch tall. The single cells are arranged together in an array and then inserted into a battery pack. With this configuration, the use of available space is increased by over 50% compared to conventional cylindrical lithium iron phosphate batteries. Compared with ternary lithium batteries and traditional lithium iron phosphate batteries, they hold notable advantages in their enduring longevity, price, charging time, and high safety. The Blade battery can be charged and discharged more than 3,000 times. If the battery life is 400 kilometers per charge, it's equivalent to 1.2 million kilometers in the battery life cycle. In contrast, Tesla batteries can last for about 300,000 to 500,000 miles, which means 1,500 battery cycles. To make it simple and clear, Tesla batteries can last 20 years depending on the driving sessions. When it comes to comparing lithium-ion, the next generation BYD batteries have a lifespan of 60 years, which means the BYD battery life is significantly longer than the 4680. Secondly, the new variant will probably be a cheaper version, with rear-wheel drive only and a smaller battery. Since 2010, the average price of a lithium-ion EV battery pack has fallen from $1,200 per kilowatt-hour to just $132 per kilowatt-hour in 2021. For comparison, BYD Blade batteries are cheaper and contain no cobalt or nickel. An estimated 55 euros per kilowatt hour or $64 per kilowatt hour. It seems Tesla is looking to produce a less expensive Model Y at a time when inflation is rampant in Europe. In terms of fast charging performance, Tesla is a high current solution. At present, the charging current of V3 is already at the level of 600 amps, and the maximum power can reach 250 kilowatts. BYD uses a rated voltage of 570 volts with a maximum of 680 and a peak power of 120 kilowatts. Blade batteries can be charged from 10% to 80% in about half an hour. Furthermore, thanks to their 800-volt operating voltage, they can provide a range of 90 miles or 145 kilometers in just 2 minutes of charging with the next-generation BYD Blade battery innovation. Although Tesla's peak power is high, it can only be maintained for a short period of time. BYD Blade batteries love being at 100% charge or at 0%, but lithium-ion batteries prefer to stay in the 20 to 80% range. The most important information is that BYD uses LFP chemistry. The LFP has a much lower energy density than the NCM/NCA chemistry of the current cells used by Tesla and other EV manufacturers. A negative chain reaction due to high pressure and high temperature causes thermal runaway in a lithium-ion cell. Since NCM, or nickel cobalt manganese cells, release oxygen as a byproduct during thermal runaway, they tend to catch fire very easily. On the other hand, the Blade battery offers a higher level of safety than conventional lithium-ion batteries. LFP is more stable battery chemistry, even at temperatures as high as 500 degrees Celsius. Following an exhaustive development program, the Blade battery returned truly impressive class-leading test results where a stringent nail penetration test confirmed the Blade battery surface temperature reached a remarkably low 30 to 60 degrees Celsius, all while emitting no smoke or fire. Further tests subjected the Blade battery to a 300 degrees Celsius furnace test and a 260% overcharging test, neither of which resulted in a fire or explosive response. The results provide evidence that the Blade battery dramatically outperforms traditional ternary lithium batteries and lithium iron phosphate technologies. This compact design, coupled with class-leading safety credentials, offers a marked competitive edge for BYD and, moreover, a step change for the entire EV industry. How do you feel about Tesla using BYD batteries? Let me know your thoughts in the comments section down below. Otherwise, that's it for today's episode. We sincerely thank you for watching and for all of your support of our channel. As always, if you enjoyed our video, please leave a like, share the video, subscribe to the channel, and ring that bell to stay up to date on exciting developments in the world of EVs. And be sure to leave a comment down below to tell us what you thought about today's content. Once again, we thank you so much from all of us here. We hope to see you again next time. Until then, take care and be safe.